Secondly, if you are just joining us as a teacher, please add your name and the grade you teach in the chat so we have an idea of who's here with us. I'm Teresa from Community Resources for Science, and Corinne is here. And most of you know Corinne, who helps you get your basis lessons and your bulletins about the support that we provide. And so we're excited to welcome presenters today from the Planet B Foundation. We've got Danielle Klein and Deborah Thomas. Oh my gosh, sorry, Deborah, I should have put my reading glasses on. Say your last name for me.
It could be Tomaszewski or Tomaszewski for those people who know the Polish pronunciation.
Lovely. So welcome teachers. Thank you for joining us today. We, as I mentioned, will be recording this, so you'll be able to share this with your colleagues, and we will be sharing resources out for you, so you will have opportunities to use everything they get to learn about today. So welcome, Danielle and Deborah, and I will let you take it away.
Thank you, Teresa and Corinne, for having us here. So excited to be working with your teachers here. We are Planet B Foundation. My name, again, is Deborah Tomaszewski, and I'm the Executive Director and Founder. My husband and I started this organization as a grassroots organization. I used to be a teacher. My husband was a beekeeper about 11 years ago. So he's our beekeeper. Full-time job as a lawyer. Part-time job is being our beekeeper, and I run the organization. We became a 501(c) about 6 years ago. So we may have been in some of your classrooms because we now have a national program, but we were an on-the-ground program in Northern California before the pandemic. We used to bring bees into the classroom. We had about 9 STEM lessons, and we use bees. We love bees. They are struggling, but we really teach about bees as a pathway into STEM learning and a springboard into environmentalism. And we love to teach about bees. We know that they're taught in the classroom, so it's a wonderful way for us to introduce the concept into youth and kind of shape green-minded thinking, is how we like to put it. Today, we're so excited to present our new distance learning program, which is available for everyone, mostly at no cost. 99% of our lessons last year were free. Sometimes some private schools pay the fee because they have a grant or whatever, but for most schools it's free, and that's sort of our dream and our goal, and we fundraise in order to be able to do that. Danielle today is going to be introducing our new program. I think you're going to enjoy it because we have we've kind of taken out some of the fun parts of the lessons for you guys to do as students. And we'll be talking about the next generation science standards and how they're incorporated. Most of these lessons are things that you're probably doing in your classroom in snippets anyway, so they line up with the different grade levels in the Common Core, so you'll be able to translate those standards into other lessons. We also have a live Google Doc for people to take notes, and we'll put a link to our registration on that page, and we have time for Q&A and interaction. So I'd like to introduce Danielle Klein. She's our lead teacher. She teaches online at Johns Hopkins, has been an elementary school teacher for years. And we were lucky enough to get her on staff, and she's not only does she teach, but she helps us develop the curriculum. So she's awesome. Anyway, take it away, Danielle.
Hey, welcome. Hello. I know most of you are in California. I am coming to you from Pennsylvania, so a little bit chillier where I am. Hopefully you're starting to see the bees because we are not yet. But as Deborah said, we are Planet B Foundation. We are working to change the world by teaching kids about bees and bees about kids. In our workshop today, our goal is to share with you not only a little bit about who we are and what our mission is, but to give you a bit of a taste of what our lessons include. As Deborah mentioned, our lessons are generally free for most populations of schools, if not a very low cost. We join your classroom virtually, so we use Zoom and Google Meet platforms to teach our virtual lessons on bees that are STEM-based engineering mindset, to include math and reading standards that you are already reaching in your classroom. We just provide kind of another way to look at them. And at the end, we will have time for questions and discussion. The Google Doc that is being shared in the chat, if any of you would like to add some notes, some suggestions, things that if you hear things that we're doing and you have any ideas of how we could even use them differently in classrooms or anything you want to share with us, feel free. And then when we all leave, you'll have the link to that doc. So anything that is shared, you can take away, as well as we will be sharing a link to our website and our online materials that you can use in a follow-up session with your class. So you are going to take the place of the kids today as we go through. We have 4 different STEM lessons that we use in the classrooms. The ones that we are viewing today are for K-5, but we do have our program goes all the way to 12th grade. The older lessons, all of the lessons cover virtually the same topics, but in different grade appropriate age level ways. So though you may register for a lesson for kindergarten or 5th grade, you are going to get a lesson that is tailored to what your school and what your class is teaching. Okay, so again, we are San Francisco based, we are a nonprofit, and we are interested in using the bee as a way to introduce STEM to children in a way that there are lots and lots of things going on in the world. Climate issues, environmental issues can be a little bit scary and overwhelming for children. So by using bees, we are able to use a non-threatening, kind of cute, fuzzy organism that all kids can relate to no matter where they live. Even if they're living in a more urban environment, they've probably seen a bee and can relate to the fact of taking care of them. And hopefully that will grow to a foundation that allows them to be more green mindseted as they grow and spread out into the world and want to take care of other organisms. Okay. So this is just a glimpse. The next couple slides show that our lessons are not just random. We do include next generation science standards as well as Common Core math and reading standards. So throughout the lesson, you will see little boxes on the bottom of some of the slides. Those slides are just giving you a glimpse of some of the standards that we incorporate with our lessons. That is not all of them. And if you are interested in finding out exactly which standards we do incorporate in everything, please feel free to visit our website where you will find links to all of that information. Okay, so our lessons focus on the 2 types of bees. We have our native bees and our honeybees. So many children are surprised to learn that not all bees are honeybees, that there are other types, and you may have even seen a bee that you didn't even realize was a bee. Because I know personally, some of them I don't recognize as bees at first. They look like way different than the traditional honeybees and bumblebees. But if you know anything about any of the species of bees that you would like to share, please feel free to chat or just let me know. Again, you are our students today. So we're going to have some discussions like we would with our children. But there are over 4,000 species of native bees in North America. They are spread out on every continent across the world except Antarctica is the only continent with no bees. Your honeybees are the more traditionally seen bees, but they are not native to North America. They were brought from Europe for the purposes of pollination and honey making. So our first lesson focuses on the honeybee. And our lesson that we're going to take a look at is our beeometry lesson, where have you ever wondered why bees use hexagons in their hives, why that cell is that shape? So in this lesson, students just like you are going to work through the engineering process as they make a claim and decide which shape is best, and is it really an accident that nature put that hexagon in there, or is there a reason? So you can see our honeybees are ready for some math and some science as we take a look at the fact that, first of all, bees are very busy in their hives. They do lots of different jobs from the time they are born all the way throughout their life. They are constantly learning and constantly growing and changing in their roles, just like you would be at home. Imagine, though, if you had to start your first chore list the day you were born. So the day you emerge from your cell, you have to automatically start cleaning your room and helping around the house. So not exactly ideal, but our bees start out that way and they work their entire lives. But in beeometry, we focus on the wax maker bee. That bee is a later in life job that they do inside the hive to provide those cells for the entire community. But bees have to be efficient with their resources. Just like us as humans, they cannot overuse. They only have so much time and energy in their day. So to make that wax requires them to chew and the pollen and use their resources and work constantly. That little tiny bit of wax actually takes 8 ounces of honey to make just 1 ounce of wax. So they are working constantly and they don't want to waste that. Just like we have to be conservative with our electricity use, our water, be mindful as humans, bees have to be mindful as well. So when a bee is considering what shape their cells should be, they need cells that are able to interlock, fit tightly. They need to be very strong. It needs to be able to hold their babies or their brood. They need a small amount of wax so that they are able to be efficient with those resources. And they need something that is strong and can store all that honey. So honey, wax, broods all have a weight. You do not want your hive to collapse. Anybody want to take a guess at any shapes? So we know as adults that the hexagon is there, but why? Would you, if you were a bee, would you consider any other shapes that might work? If you want to write down your claim or chat your answer to me of what other shapes you might think could work in a honey bee hive.
And Danielle, we have a comment in the chat asking about, is it because of how the bubbles clump together when they touch, bubble molecules? Does that have anything to do with what you're talking about?
Well, as you might see, we have a video in our children's lesson, but as if you watch circles long enough, and we actually do use a bubble demonstration with our students, that if you blow bubbles into a soap solution long enough, and that is one of our classroom activities that we do, that you will see that those circle bubbles do start to push together and flatten out on the sides to become hexagons. So that is definitely part of it.
And there are some shape suggestions in the chat. It's someone suggesting rhombus. Someone else is saying circles, but they don't quite fully connect. Thinking of quilt making as a kind of comparison. And someone's talking about, oh, Deborah's saying bubbles make hexagons. So great.
Yep. Okay.
Danielle, I just wanted the sharing doc doesn't allow everybody else to edit. So
okay, I will see if I can adjust that. I'm sorry. It should be set that anyone has the link can edit to it. So
yeah, I go into it and it just allows me to view. And that's,
you know what? Yeah, I'll fix that right now. So
yeah. Sorry, everybody.
We'll get that fixed.
Fun technology glitches. Gotta love Google. All right. So now that we have made our claim and we are starting to consider different shapes as students do, we work through our main ones that the students name are the hexagon, the triangle, the rectangle or square, and the circle. So we will use a process of elimination to find out why indeed the hexagon is the best or isn't the best. So the first one, as we gather evidence on our various shapes, so with students we work through a checklist of which shapes are better and why. You can see that as circles have that wasted space. You don't want that wasted space. If you are a wax maker bee, you would have to make a lot of wax to fill that so that they do ultimately connect. And again, that's a waste of resources and a lot of extra work, as well as because circles, if you ever try to hold some bouncy balls together in a group, they don't stay. So our next shape that we need to consider are rectangles or squares is another popular choice. But what could possibly be wrong with a square? It looks like they fit nice and tight. You as a wax maker bee have some easy lines to make, not very complicated, not a lot of extra space to fit. As you can, however, oh, slide jumped ahead. However, they don't have the center support that a lot of other shapes have. So, and with our students, we view some slides that will show and demonstrate the lack of center support in the squares. But they have some, so they meet some of our needs, but not all of them. Our triangles, again, no wasted space, and they do fit tightly together. So again, they are checking some of those boxes. Can anyone think of anything, pros or cons, that would work for a triangle? Okay, yeah, you don't need the corners. It can have less wasted space. And yes, if you use enough of them, they're going to become those hexagons, which is a very good observation. Just think though, if you are using triangles to create your hexagons, you have those interior walls. So that is one thing to consider versus the triangle method instead of just the hexagons. Then of course we do have our hexagons. You can see that they fit tightly together. They do not have wasted space. They are a strong shape when grouped together, thanks to those sides pushing the weight, redistributing it out to the outer edges. They will not need that center support like a square. But yes, whether or not they are small, I see some people are concerned about their size. Remember, we want it to fit well so that it's like a nice, warm, cozy jacket for you on a cold day. You want to be able to tuck your baby bee in nice and tightly without a lot of air around them. And as a wax maker bee, you don't want to have to put too much extra effort into this project. So hexagons are checking some boxes, but so are triangles and so are squares. So we need to continue with our investigation. This is where we bring in some of our math of looking not just at the shape's attributes, but their area, their perimeter. So with elementary school age, we generally focus on the perimeter. And as the students get older, we get into area, just because area of some of these less common shapes gets a little tricky for the younger students. So we are going to focus on using perimeter to help support our decisions. Okay, so perimeter, again, the space around the outside of a shape. Okay, so if you can, and you're in the air, you can trace for me. We're going to do the perimeter of a square, the perimeter of a triangle, and the perimeter of the hexagon. So we are going to go around that outside of those shapes. Okay, hope you brought your math skills with you. Okay, so we first are going to calculate our perimeter of our square. So if our square has 4 sides measuring 5 inches each, we all know that squares are squares because of having equal sides. What is our perimeter? So those of you that prefer repeated addition, we know that multiplication is using exactly equal groups, but repeated addition is just another way to do multiplication. So either math you're more comfortable with. Anyone want to tell me what the perimeter of our square is? We need to get 4 hands out. Everybody has 4 hands, right? Maybe borrow a bee, they have 6, so they could add off groups of 5 for you. Yes, 20 inches. So we have, keep that in your mind, because we are going to be comparing our shapes. So we need to remember the perimeter of each shape, and we're going to talk about in a little bit why that would matter to a bee, why they need to consider perimeter. And so 20 inches for our square. If we look at a triangle that also has a side length of 5 inches, and we're looking at an equilateral triangle, so all of our sides are equal. Again, you may use multiplication or repeated addition, depending on what you're comfortable with. But what is our perimeter of our triangle? Anybody know? Could maybe use some toes on this one. You have at least 3 sides, a little less to do. Yep, 15 inches. Okay, so hang on to that number. So far we have a square at 20, a triangle at 15, and there we go. And bless you. And we have a hexagon now. Now, if you notice, our hexagon sides are 2 inches. There are more sides. They are not quite as long to cover the same amount of space, because the way the angles, the lines of the hexagon, it is able to use shorter sides. That's important to keep that in mind. But there are 6 of them. So maybe borrow a bee friend that can help you add 6 groups of 2 repeatedly or multiply 6 times 2. But what would our area be of our hexagon? Any guesses? Yep, 12. Okay, so we have our areas of 20, 15, and 12 respectively. For perimeter, sorry. Oh my, okay. So looking back at the perimeters of each of our shapes, why does perimeter matter to a bee? Any guesses? Okay, yes, the perimeter matters because, again, you are building the outside of the cell. Other bee friends in your hive will fill them with nectar, brood, anything that's going to go in them. But this one, you are the wax maker bee. You need to build the perimeter. You don't want extra work. Okay, so you are going to want a less perimeter to have less work in building a shape. It also goes back to that wasted space. Even though some of the other shapes may be a little larger, if that's larger than the bee needs for its brood or nectar, they're just going to, again, fill that in with extra wax. That's just extra work for you.
There was a question about the, how did you decide on the size of the shapes? Is that just a given?
Okay, so for our demonstration, the reason that we use those sides are because they are a side length that is easy for kids to use. They're in 5s and 2s are an easy number, plus calculating, again, the area, it comes out to being shapes that are roughly the same size in area. And then the shapes, again, the numbers allow kids to get the concept in an elementary friendly way.
And if kids ask, why not use 5 for all the sides? What's a simple explanation for what would happen if you use 5? You would be comparing, you know, different.
Right. Sides. So you would be you would not be comparing ratio wise in shapes that are the same size. Ratio wise, your hexagon would be huge. Because of the 6 sides at 5 inches apiece, you would be creating a hexagon that has a much larger area than either the triangle or the square. So then comparing them in other ways, it's not going to be a equal proportionate comparison. Okay, any other questions? So as we look at not just the perimeter, and we're looking at the fact that our shapes, as we go inside of a hive, they are not sitting singularly. So with students, we work through a progression of slides. Time-wise, this is the end result. But you can see that the shapes share sides as we go. So again, you are the wax maker bee, and all of those numbers of perimeter, we're going to tie in again. So just hang on to them. As you work and stack your cells, because you're not just building one singular cell in the middle of your hive, you get a little bit of a break. So those cells in the middle, you can see you would only have to build 2 new sides for those shapes. Very few of your squares actually need 4 sides made as they begin to share. So total in this diagram, you would need to make 3 rows of squares, you would need 59 sides of squares. Okay, keep that in mind. If you wanted to make triangles, okay, again, as you're going with your rows of triangles, again, for 3 rows of triangles, your triangles begin to share sides as well, and some of them you only need to make 1 new side. That saves you as the wax maker bee a lot of work. So total for these rows of triangles, you only need to make 43 sides. And again, with students, we work through a progression. So they work up to adding these numbers and having the rows built. For 3 rows of hexagons, you need a total of 81 sides. Now, sounds like a lot. Sounds like a lot of extra work for the wax maker bee, except considering the length of your sides, and because a hexagon, again, can use more shorter sides to make its shape and have a similar area of space. Even though you are building 81 walls, they are shorter. So altogether, for the hexagon, you only need 162 inches of wax. For your 43 triangle walls that need to be longer to have a similar area, you are taking 215 inches of wax. And for your square, that's 295 inches of wax. I don't know about you, but as a wax maker bee, I think I'd rather save on the length and take the hexagon for the total number of inches of wax you would have to make those 3 rows of squares. Okay. So as you can see, the brood fits in the hexagon. If you look, the circles in the middle are representing striped baby bees. If you are stacking your brood in your hexagons, you can see that it's a nice tight fit without having a lot of extra space around the bee. You have your squares, you would need to fill those corners in. And as well as the triangles, again, as a wax maker bee, you would be filling in those corners. So again, as far as extra space and the amount of work for a bee, nature didn't pick it by accident. There's a reason that they chose the hexagon. It is a strong shape that allows for shared sides, that allows plenty of room for your honey, your pollen, and your brood. And you can see that nature uses the hexagon in other ways, as in the shape of the scoots on the back of our turtle. You can see the hexagon here in the middle. Okay, so nature has a reason for what it chooses. Any last questions on the taste of that lesson? Again, that is a taste of the lesson that we do with students, that builds through it in a little bit different way with the kids so that it works up to those connections.
And Danielle, can I just ask a question about the lesson itself and the resources you'll be sharing with the teachers? This is such a great example of the cross-curricular connections between science and math and even engineering. Do you have some sample prompts for, because it can also easily connect very well with language arts in terms of the use of the science notebooks? And I can imagine teachers thinking of ways that they can have their students use their science notebooks to make tables as they make these calculations and compare the data. Do you have some examples of prompts and the types of data collection that the teachers could use with their science notebooks?
We do in our Google Classroom and in our resources that we will be sharing links with at the end. You will be able to access student handouts as well as teacher resources that could help in teaching similar concepts and things that you can apply with your kids. So we have things that when we teach a lesson, we have worksheets that the students can work through ahead of time while they're in the lesson, as well as things that you can do to follow up afterwards. So thank you. And our next taste of a lesson is called,
Sorry to interrupt. One last couple connections I made. I'm with CRS too, and my wife's a teacher at TK.
hello.
Oh, hello. Can you hear me?
Yeah, I can.
Just a couple connections I made that were fun. One is geodesic domes, also hexagonal, like the turtle shell you shared, which I never thought of. That was really cool. And then, you know, those of you that are Settlers of Catan nerds, you know, these are great puzzle pieces, right? I mean, you don't even have to do the game. You could just have the kids explore with that. And then the third thing was sort of common denominators. I did the little chart, like you were saying. I didn't think of the walls, but I thought of the area. And when you get to common denominators, you can see that the area is definitely bigger when you get to the same scale. You know, like it was definitely, the proportions were best for the, like you were saying. So yeah, a lot of, like Teresa was saying, a lot of great cross-curricular connections with math and shapes and geometry and stuff. Thanks
Thank you. Thanks for sharing those. We love other ideas too from all of you. And so hopefully our doc is up and running, but if not, I will make sure that it is and shared. I know that resources will be shared even after the lesson too. So thank you very much. And yes, with the students, again, this is our elementary version. So we are trying to keep it in ways that use the geometry on the level that the we use the Common Core standards because since we teach across different states, it allows us to connect in a way that is not necessarily, it's for everybody. So we use them in an elementary friendly way. In this version of the lessons, they do go a little deeper, a little more complex as we get into the middle school and high school lessons. So our next lesson is do the waggle. So hopefully you are ready for a little dancing. Okay, as we learn a little bit about how bees communicate and what they have to say to each other. Okay, so you can see our bee friend, he's trying to order some honey, but she can't quite do it that way. Okay, so this lesson helps kids to focus on communication, communication between themselves, communication between humans in general, and communication between animals as we work towards our communication of our bees. So with students, we work through a progression of talking about that they can connect to themselves, which is important, especially for the elementary ages. We find that they like to not only learn about the bees, but we get to spend some time talking about humans and other organisms, because again, we don't want just a bee focus. We want them to leave our lessons with a foundation that they can grow a green-minded thought process that can be applied towards all organisms. Okay, so our antennas allow our bees to communicate. So if you want to put your antennas up, you can try to communicate a message with us. Hopefully, it is a message that you're enjoying the lesson. And again, we let students try to communicate, but what are our bees talking about? They are talking about everything from the moisture in the air, the wind, the air quality, the temperature, the food that's available, and most importantly, the food. We all like to know as humans where the good restaurants are, what the good grocery stores are, what's on sale that week. The bees are no different. Food is very important to them, so they are communicating about where the best flowers are for the hive. A bee can visit as many as 50 to 100 flowers, and this time we are focusing on our forager bees. That is the last job a honeybee does. So they are off every day foraging to visit as many flowers as they can, but when you see that bee landing on a flower near you, it's actually covered quite a bit of distance to get there. The waggle is the dance that the bees do to communicate with each other. It is based on direction. It is also based on distance and angles with the sun. Okay, so this lesson, again, is a taste and an elementary friendly version of angles as well as direction and a little bit of math, because every second that the bee waggles is a kilometer of distance that that bee flew. So as bees are flying from their hives, they are considering the sun for their direction. So as you are a bee flying to a flower, you are going to be keeping an eye on what side of your body or what your relevant location is to the sun. And when you get back, you're going to dance to tell your other forager bee friends where they can also go to find that delicious food. Okay, and we use the curved, the bumpy. Every bump is just a visual representation of the dance that the bees are doing. So they are not actually bumping up and down. As you will see, they are actually dancing in a figure 8 pattern. And again, with students, we go through a whole progression to get to these points, but that a kilometer is the same as 3,280 feet. Okay, and as you can see, the bee doesn't have quite enough, but the centipede is willing to help. That, here's a small little dance. If you can see, the bee in the middle is blue. That bee is waggling. That bee has found some delicious flowers and is sharing with its friends where they can go find some as well. Remember, sharing is caring, and the hive needs the food, so they all want to know. And we want to keep on waggling. There we go. Okay, so we are going to work together as scientists and mathematicians to look at angles and decide, are our bees waggling correctly? So as we work through this with students, we look at a variety of examples, including this one. which bee waggled correctly? So hold your fingers up for me. Is bee number 1 or bee number 2? Who has the better waggle? For that example in the middle of the 4-kilometer distance, who got a little lost and who made it? Okay, I see lots of number 1s and a few number 2s, quite a few number 2s, because yes, number 2 is our waggling bee. So number 2, she found the flowers correctly. She knows where she's going. And yes, that one says 5 in the middle. Got copied from the wrong one. But we worked through a whole bunch of examples with the students, with the kids. And so yes, that probably got pulled from 2 examples. But that is a taste of our waggle lesson. Our waggle lesson, again, works through communication with math. It works through angles. It works through distances with the sun. It works through reading a compass and knowing your intermediate directions as well as your main directions of north and south. And it also works on estimating, as the kids have to then figure out which flowers the bees would have visited based on which distances they are given. Okay, any questions on the waggle before we move on to our next lesson? Any connections anybody wants to share?
I can imagine the kids have a lot of fun trying to do the bee waggle.
They do. And so again, we try to make our lessons, especially at the elementary level, very play-based and not only cross-curricular for the academic benefits and for the teachers, but the students, again, virtual learning can get daunting. All of us, even just sitting in front of a screen or a meeting for an hour gets to be a lot. So with the kids, these lessons, all of them have points where we can get them out of their seats. They can do their waggle. They can interact through chat. They can talk to us. We encourage as much interaction as possible. We do not teach quietly, which can be interesting sometimes, but we like the kids to be involved. So as they would do that lesson, they would stand up and show us their waggles. They would use their antennas. And in this lesson, you're going to get to stretch your wings. So our next lesson is Want to Be an Engineer. And if you know anything about engineering, it has to do with building and creating and problem solving. So this lesson focuses, the first 2 are on our honeybees. These next 2 lessons focus on our native bees. So this is going back to our 4,000 plus species of native bees that we see throughout the US. Okay, so just as a foundation, native means that you are living or from the place where you are originally from. So an easy connection that kids are able to make is the fact that polar bears are native to the Arctic. Okay, we may see them in places like zoos or aquariums that allow us to visit them and learn, but that's not their native habitat. Where they come from is the Arctic, and that's where they are best suited. Our native bees come originally from North America and are suited to living here and are an important part of our ecosystem here. So through our student lessons, we focus on 4 main native bees. The reason we do this is, again, it narrows it down to examples that the students are able to see. We do teach across the US, and even we've taught some Canadian lessons. So we've narrowed our focus to bees that the students would be able to see in some part of their environment. Our mason bee, our leafcutter bee, our bumblebee, and our carpenter bee. So no matter where in North America your students are located, they've probably seen at least one of these bees. And as we work through Want to Be, we talk about the differences in the species. We are able to do a lot of, so for those ELA connections, comparing and contrasting that even though these are the same species of organism, as you can see, they look very different. Does anyone want to point out or share any of the differences or similarities you see between some of our bee friends? Okay, yeah, they have definitely some different colors. There are some that are fuzzy, some that are not. We can even get into colors and shapes and sizes of their wings. But the important thing to remember is that all of these bees are amazing pollinators. And that's what we're going to focus on in this lesson. And this lesson takes more of a conservation edge too. So when we talk about our bees, we're going to learn how we can help our bees. Okay, so as you can see, our bee friends are pollinating so many foods for us. I personally could not live without the bumblebees because I am a French fry addict and they pollinate potatoes. You may not think of it because they grow underground, but the flower or the blossom is above ground. They are pollinated by our bumblebee friends, as well as things like blueberries, raspberries, almonds, plums, just about every fruit you can imagine, onions, even alfalfa, which I hope we've all had a good helping of today. But if you're like me with horses, you know what a treat alfalfa can be to some livestock. Okay, now with our students, we work through a progression leading up to this, but I'm just going to give you a cold hard quiz. Where do you think each bee lives? So if you were reading my slides, you got a taste of the types of habitats they like, but I'll give you some clues. Our first bee, our mason bee, just like the name implies, masons work with bricks and mud. Our mason bee needs mud to live in tubular spaces. Our bumblebee loves underground cavities and leaf litter. The leaf cutter bee, as her name implies, loves leaves and needs access to them for her tubular spaced homes. And our carpenter bee has extremely strong jaws and loves to chew wood. So if you can chat to me or share with me through numbers, but number one, our mason bee, which home do we think our mason bee is living in? And yes, two of the pictures show tubes in the same bee house, but pay careful attention to the material at the end of the nest. And yes, number one, our mason bee likes home D. You can see the mud at the end capping off that tube. Our bumblebee, number two, where would our bumblebee live? Home A, B, or C? Yep, no fooling you. C, yes, our bumblebee will nest, and our bumblebee is different. And a quick fact about them is that unlike many native bees that live solitary lives, our bumblebee will live with about 100 roommates. They can even live with up to 150 in their nest. Sounds like a lot, but since honeybees live with about 50,000, it's a few less roommates. Okay, so our leaf cutter bee, number three, which home would our leaf cutter bee enjoy, A or B? Yes, yep, you can see the green leaves she has lovingly tucked into her home, preparing for her nest, for her eggs inside. And our carpenter bee, last but not least, is home A. Our carpenter bee sadly gets a bad rep for those wooden holes. A lot of people look at the carpenter bee as a pest, but that carpenter bee will not destroy your home like a termite would or another pest. It will use the hole for its nest, and once it leaves, you can safely plug the hole. So that's something we always like to share with students so that they know if they see a carpenter bee, they don't need to treat it as a pest and kill it, because they are important pollinators, especially if you like tomatoes. Okay, and so this represents a video that we share with students. And in this lesson, the reason it is called Want to Be an Engineer is that as students complete this lesson, we actually work on making a native bee house out of found objects like recyclable water bottles, grocery bags, paper bags, or another thick paper material. This would be a video that the students would watch. And after the video, we would talk about the important things that they have learned in the video as far as hygiene and as far as taking placement of their home. So the home needs to be placed out of the wind, out of the rain, and you need to make sure that you replace the tubes in it. But again, this is an actual hands-on activity that we do with the students in our lesson that not only reaches, many STEM standards as well as math and problem solving, because they have to measure and figure out the lengths and for their numbers, for their tubes, and we also do some estimation as far as how many tubes they can fit. And if it's an activity, because again, teaching virtually, students don't always have these materials on hand, we try to communicate with teachers to have them. If they don't though, it's an awesome follow-up activity. So they can take notes, they can learn about it, and then afterwards, that's something that they can do.
Would
Okay?
something like toilet paper tubes work?
Toilet paper tubes can work as an outside space, so you could put more tubes inside of that. Paper straws are great. The idea is that the bees aren't, again, just like your honeybees, they're not going to want it too big of a tube with too much space to fill for more work, but it is a good starting point. And even though plastic bottles are not our favorite friends and we try to be environmentally friendly without them, instead of throwing them away, this does provide a way to use them as a habitat, and it does keep them dry. Water is a big enemy to their homes, but again, we work through all of those steps and considerations with the kids so that by the time they leave, they are fully informed of how to make a safe native bee house.
There's a couple of questions about carpenter bees. Do they use old holes or do they come back to the same ones?
They will use holes that are already there at times. They do not often return to the exact same hole. Some will, many do not. So if you plug the hole, they will just either go find a hole that's already available from someone or something else, or they will just chew another one. And this is what life inside of a bee tube looks like. So when you build your house, this is what you're giving home to. So larvae packed in with delicious bee bread, which all of the kids love this part because we get to talk about the fact that mama bee chews up pollen and spits it out to make that bee bread. And that is a very fun thing when you are a kid to think of your mom spitting out food. All right, so a little bit of math, but how far do you think our bee friends? So some quick predictions, and I will annotate up here. How far do you think our bees are flying to pollinate? So how far can a bumblebee fly? Any guesses? Oh, make my chat small. Do we think that they can go as far as a mile or not? Any guesses? Okay, so the kids give us all kinds of numbers. We'll put in a 5. That's a very typical guess of a student that a bumblebee can fly 5 miles. And again, we are going to look at the distances flown as far as up and back. And yes, we have some very enthusiastic bees. We'll put in 1 million for our mason bee. Maybe, you never know. Okay, and our leaf cutter bee, how far do we think they can fly? Now remember, you have our considerations as far as size of the bee, where they might be going. So again, thinking of those plants that they pollinate, and as well as what their types of homes look like. Okay, 100,000, yes. Kids get ambitious. You'd be surprised that between either, they tend to go really large with their guesses or really, really small with their guesses. So our carpenter bee, lastly, those big heavy jaws can maybe be a little bit heavy to fly with. We'll give them maybe 100. Okay. And so in reality, again, we work through a progression with the kids, but this is what their numbers look like. So on average, a bumblebee will travel 3 miles out and back to pollinate, which is a 60 miles in a day to 420 in a week to as much as 1,680 miles in a month. 4 miles a day roughly for our mason bees. They pollinate a lot in orchards. They don't have to fly quite as far to visit a same number of flowers. Our leafcutter bees that will fly about 1 mile, again, they are pollinating plants that tend to be in larger orchards, tend to be with almonds and things that are grown in relatively more dense areas. And they also are carrying leaf material with them when they need to nest. So again, that gets a little weighty. And the carpenter bees fly about 100 miles, about 20 miles really, in a day to 140 for a week. So again, these are fun things that we do with the kids. They love to see their predictions and they love to then compare them to the real numbers, and many are surprised. And you also have to remember that these are the bees pollinating. So they are going this far for food. And the last time you had to go 100 miles for food in a week was probably not very recently. But planning a picnic if we didn't have our bee friends. So to see what we as humans rely on from our bee friends, what foods could you not have if this was your picnic and you could no longer rely on the bees for pollination? What would you lose? Any questions? Any ideas? Yep, we would pretty much lose it all. So bye-bye potato chips, goodbye to the fruit, goodbye to the lemonade and the watermelon, goodbye to the chocolate. Now, cocoa beans are not pollinated by bees, but many of our chocolate bars include tasty ingredients such as vanilla, and vanilla is pollinated by a bee. Your pizza, you could have it, but it wouldn't look the same. You would lose your tomatoes for your sauce and toppings and any vegetable toppings. We would lose our apple pie as we know it. Bye-bye apples. You could have your dough. Grains are wind pollinated. They do not rely on our bees. So again, as long as you're okay with apple pies minus the apples. And our hot dog, you could have it plain. Ketchup and mustard both rely on mustard seeds and or tomatoes that are bee pollinated. So again, as long as you're okay with a plain hot dog, you could have your plain hot dog, your pie dough, and your pizza crust, and it'd be still a tasty picnic. But the kids always have fun with this part and trying to guess what we would lose, and they are always amazed. But again, it ties in that green-minded foundation of the fact that we do rely on bees for quite a bit, and that our lives would definitely be affected. Okay, and here you can see what the pollination of a day can do for us as humans. A bee can visit as many as 2,000 blossoms in a day, which if you are looking at an acre, again, many of our bees do visit orchards. Okay, so about 100 trees, 150 trees on an acre of land, a small orchard. Each tree can produce about 100 apples, which is around 15,000 apples, which can feed around 1,500 families, again, buying them in sets of 10. So again, just tying in the fact that we rely a lot on our bees. And with students, again, we would work through these progressions with predictions, estimations, letting them actually help with the math of it.
Danielle, can I ask a question in terms of what kids might ask? Your lovely slide with all the food on it. Around here in the Bay Area, often in the spring and summertime, when you're out trying to enjoy lunch on the schoolyard or a picnic, you get pesky things that look like bees that fly around, and then maybe they're wasps or hornets, and kids become like, I don't like bees. I'm afraid of bees. Bees come after my food. Do you talk about the difference between bees and other types of things that look like bees?
We do. And that is a big part of our talk at that point, is that those pesky bee-like invaders of your picnic are your wasps and yellow jackets that are similar in some ways to bees, and you may confuse them with bees, but that's why bees get a bad rap. The bees that you see at your picnic are not the honeybees and the native bees that we are trying to help and protect. Those are your wasps and your yellow jackets that are carnivorous, and actually our honeybees do not want to sting you. So I know we are getting low on time, and we do still have many activities that we do with kids, but this is always a favorite. So I want to make sure that we fit it in before we wrap up with the last couple of things. This activity, you need to stretch your wings. You have been listening to me talk, and we've been sitting here together very patiently with our listening antennas. But now we know how far a bee can fly, but what is amazing is how fast they flap. So if you clap your hands one time, in that 1 second, a bee flapped about 200 times. And we have a short video that we go into with students so they can actually see a bee flapping its wings and how fast that is, even slowed in slow motion. But a bee flapped 200 times. I'm going to time us for 30 seconds. In 1 second, a bee can flap 200 times. How many times can you flap in 30 seconds? So we will look goofy for a minute, and the kids always do. But if you stretch your wings out, and we can flap for 30 seconds, and then we will share how many times we were able to go. On your mark, get set, go. And 5 seconds. And go. Okay. So some of us do look like we are ready to take off, but anybody want to share how many flaps they got in that 30 seconds? Okay, great. So a lot in the 45 to 30 to 45 range. I personally got about 42. So again, as students, we would complete our graph and we would work through comparing the numbers and speeds, but those bees and our 30 seconds where we might be impressed and the students love it if they can say they got to 80. We always have something to do, whether they do or not, but it's still nothing compared to that. In that 30 seconds, that bee would have flapped 6,000 times. So we have a little bit of work to do before we catch up to them. But it's okay. Okay, so another activity we do is just talking about with students if they could plant a garden. With our older students, we will actually get out graph paper and a grid and kind of work through planting a bee-friendly garden with foods you love that encourage bees. Adaptability is our last lesson. Just kind of go through it quickly. But adaptability focuses on the adaptations of humans and bees to survive in a wide variety of habitats, focusing mainly on the adaptations that allow bees to carry pollen differently, to pollinate for us and for themselves and the ecosystem. Okay, and the fact that bee buzzing is not an accident. It is not just a sound that they make by accident because their wings are flapping so fast. It actually is helping them to stay warm. It helps them to buzz pollinate, reach pollen in the plants. And with the students, we work through the fact that bees need a certain temperature as well as a certain amount of sunlight to pollinate. So this one works through fractions as well as adding and subtracting, graph reading, as students work through whether or not the bee can fly that day. This particular day was not enough. The bee was sad. The bee does have some happy times. Before we finally wrap up after this lesson with temperature and numbers and go into the ecosystems. And all of our lessons end by comparing the bees with our ecosystems, as well as how we can help our bees in a world of constantly changing climates and constantly changing environments. We as humans can do a lot, and small decisions will help not only the bees, but each other and other organisms. So I know those last few slides we went through kind of quickly, but if you would like to know more about our lessons, we have lots of information on our website, which we'll be sharing all of our links for. Our lessons, again, are free to most students. They get an hour of our time as well as access to our videos. We have great videos for prior to our lessons on native bees and honeybees. And it also gives you as an educator access to all of our free resources for your own bee knowledge, as well as worksheets and handouts the students can complete, including a science journal of different types of native bees and adapting a bee to an environment of their choosing. So hopefully we'll see some of you in classrooms soon. But if anyone has any questions or last things they would like to share.
Thank you, Danielle. I'm going to just really appreciate that you covered such an amazing amount of material in such a short time. It's really awesome. We will be sharing these resources out with all of you who are attending today. And we can stay, I am just being mindful of it's 11. So thank you, those of you who might need to hop off, but we also can stay on for a little bit of time. If there are people who have questions, feel free to hang in there with us and we will take your questions. Thank you all for joining us today, and thank you for Planet B Foundation. And this is the first of our series of maybe a dozen or more workshops that we'll have focused on environmental and climate literacy this spring. So please tell your colleagues and keep checking back for more. Thank you so much, Danielle.
Yeah, thank you to